Hello. So we start. Hello everyone, my name is Hello. Today is my presentation and my name is Chen-Chieh Peng. I'm from NTU and my topic is greenhouse heating and cooling with a heatful system using supply and underground water thermal energy. Okay, this is my outline. First, I will introduction, after method and result, and the final conclusion. Okay, first we need to know what is greenhouse. Greenhouse is building or complex in which plants are grown. Greenhouse allows a greater control over the growing environment of plants, which may be controlled and temperature level 9 and another. But here's the question: why we are using a greenhouse? Because here's the greenhouse. Because in the future they are sown in the place where we plant. How we need to burn more and more greenhouse. And the greenhouse are often used for growing flower, fruit, and another plant. Some of the greenhouse and some place use greenhouse to plant tomato, and the tomato is one of the fruits in the most important fruit in the world. There are some pictures of greenhouse. Here we see the tomato and some fruit and some fruit we can eat. And now we present the new energy. The new energy, like said, supply and thermal energy, is we convert the solar radiation into and thermal energy. So if the outside is very cold, the indoor can be more hotter than outside. Then another energy is called underground water thermal energy. It's if the outside is very hot, the indoor could be colder. But thanks for that to energy. For example, as we see, if we use the two energy, the temperature of outflow is very hot, very low, very cool. Or the indoor of the greenhouse is very hot, so we can grow the plant. And what if the solar is very intense? The indoor temperature of greenhouse ground. If it's over, we can save the energy. For night or for day, they are not energy. And say that energy are very important because in the future we need our future food, so we need use to that greenhouse and to energy to increase agricultural benefit. Thank you.
Any questions? Yes, please. Can you make some definition to the greenhouse?
Okay, great. Greenhouse is a house with glass or another material like plastic. It's like house. The solar radiation can enter in a house, and in a house we can control like temperature and another for the plant.
So if today we have a building,
Yeah.
like a normal building, and we can do the same thing as you said, we can call that greenhouse, right?
If you greenhouse use a glass or plastic, when a solar radiation can enter in indoor, that's called greenhouse.
Okay, thank you. So you need to use the transparent carbon materials.
Yeah, or glass.
Transparent. Cool.
Also, yeah.
Any more questions, comments? Yes, please.
You said there were two ways, like either you make it warmer inside or you
Yeah.
can make it colder.
Yeah.
But the one you make it colder, you use underground water.
Yeah.
So how does that work?
Okay. This project is in Korea. In Korea, there are a lot of underwater, and underwater, if we indoor is very hot, so the underwater start to moving. It's like the water take the temperature to another place, so the indoor start cooling. Sorry, thank you.
Basically, it's the heat changes between the air and the underground water. So you can warm up of the air or cool down of the air. Depends on the temperature difference. I mean, of the underground water and the air. Any more questions? Yes, please.
As you mentioned, you use the solar energy to warm the greenhouse. But I think what is the difference if you have the greenhouse or you don't have? Because if you don't have the greenhouse, you also have the solar energy. So how do you make it warmer with the sunlight?
They are mentioned we save the energy and the solar radiation, and that mentioned make the indoor warm.
Maybe indoor warm.
Yeah.
Or, but if we don't have the greenhouse, we also have the sunlight.
How do you can control the temperature?
I get it. Thank you.
Basically, the sunshine from the sun, there are two purposes. One for the synthesis of the plant growth, and another we try to use the energy, not the light. Okay, so the energy is for heating up of the greenhouses, and also we use the light for plant growth. It's photosynthesis. Okay, any questions or comments from Japan?
We have one question. Hello. Thanks for your presentation. And I want to ask regarding the underground water. So in underground water, you say that it's coming from the movement of underground water. So in my mind, in my imagination, it's like a kinetic energy. So you need some kind of turbine that's moved by underground water. But how deep it is? How deep you put your turbine, if you use a turbine? If you doesn't, what you are using? To get that kinetic energy. Thank you.
Because this sample is taken to Korea, there are a lot of underwater. If the place without underwater, we need to think another way.
Okay, so basically it's used a turbine.
Yeah.
Okay.
I would like to know what will happen in case there is prolonged season where we have no sunlight. For example, where we have long winter seasons where maybe the intensity of the sunshine is low. How are we going to heat up the greenhouse?
And the greenhouse have a tank they save energy for a day of the season like no solar radiation. They save energy for that case.
Could you have some data showing the amount of energy maybe that can be stored?
Yeah. Oh, I don't know what that.
Do you have the data? Do you have evidence of how much energy you store?
Oh, I don't know. How much? I don't know. They didn't mention how much.
Okay, thank you.
Are there any other questions? Maybe I can add a comment. When I was working in New Zealand, they were using that technology for tomato and paprika production. And what they were doing is using the heat during the day to pump the water down into a storage underground, and then during the night or during the early morning when the temperature was still low, they were pumping that heat of that heated water back up, and they were only pumping it in pipes that were where the fruit were. So it's not necessary to heat the whole greenhouse, but only where the ripening was occurring. And so they were able to increase production and ripening of the fruit without using a lot of energy to heat the whole greenhouse. That's all from Kyoto University. Thank you very much for your presentation.
Thank you.